during our class on plasma proteins, because plasma proteins also can act as buffer and participate in acid-base balance. So before we enter into pH, this is all about acid and base. So let's see what we understand by acid. What do we mean by acid? Acids are substances, a compound that can donate, liberate hydrogen ion in aqueous medium, in aqueous solution. Example, hydrochloric acid. So this compound, when dissociates, it forms hydrogen ion and chloride ion. So we can call hydrochloric acid as an acid, and it is a strong acid. Why this is a strong acid? It can dissociate completely into hydrogen ion plus chloride ion. Water can also be dissociated. They can also be dissociated into hydrogen ion and hydroxyl ion. But their dissociation is not complete. Water is not completely dissociated. The hydroxyl ion, so see, water can produce, liberate hydrogen ion. So in that sense, we can call water an acid. It can donate hydrogen ion, it can liberate hydrogen ion. And the hydroxyl ion with negative ion, it can also accept hydrogen ion. Water, the same compound, water can donate hydrogen ion, the water can also accept hydrogen ion. That means it is both acid as well as base. So substances which can donate, liberate hydrogen ion, they are called acid. Again, substances which can accept hydrogen ion, they are called base. So such substances are called amphoteric substances. Water is also an amphoteric substance. I will show. Amphoteric substance. Clear? But water is not like hydrochloric acid. It cannot dissociate it. Only a small portion of it is hydrolyzed or dissociated. Donating hydrogen ion, liberating hydrogen ion means liberating proton. How? There is one positive charge. So they are liberating protons. Whereas base, they are accepting hydrogen ion, means they are accepting proton. So protons are base are those who can accept combined with hydrogen ion or combined with protons. Now it is clear to you what is an acid, what is a base. Now pH. Power of hydrogen ion. P means power. Power on base 10. Integral of 10. Integral of, it is 7. So if you put only the integral in the equation of pH, what it comes? pH 7. The pH is this is the sign of concentration. If you put this value here, and express this value in negative log, this value comes 7. And 1.1 into 10 to the power 7 is the hydrogen ion concentration. Water will be dissociated, no? Dissociated and produce hydrogen ion. So at 25 degrees centigrade, at this temperature, because liberation of hydrogen ion depends on temperature, varies with temperature. So at this standard temperature, the concentration of hydrogen ion in the aqueous solution is very less. It is 10 to 1 into 10 to the power minus 7. That is, what does it mean? 1 by 7 zeros. So how much it comes? 1 by, you are dividing 1 by this. Very small. So when we will be expressing this in negative log, its value is 7. And this 7 we consider, and the concentration of suppose another compound is 004. 10 to the power minus 4. Then the pH would be 4. Whose value is greater? 1 by 1, 0, 0, 0, 0, 34 zeros, and 1 by 7 zeros by 1 7 zeros. This one is higher value. 1 by 7 zeros. Another, so see the fraction. What is the result of the, what will be the result of the division? And now you are dividing 1 by 4, 0, 0, 0, 4 zeros. This one will be higher value. Product. After division, you will get a product, and whose product is higher comparative to other. Whether this or this. When this value is replaced in the equation, replaced by 4, we will replace it by 4. It means 10 to the power 4. So when we are replacing it, the value is 4. PS is 4. PS is 4. It means here number of hydrogen are more than this. Here it is number of hydrogen is more. More the hydrogen ion, less will be the PS. Could you follow this? Another compound, another solution, it is having concentration of hydrogen are this. Concentration of mole per liter, gram mole per liter. This is the concentration of a particular solution. Now what will be the pH? Its pH will be, it means 10 to the power minus 3. So we are eliminating this. The negative block we replaced. As a result, what will be the pH? 3. Here the number of hydrogen ion, concentration of hydrogen ion is more than this. The result after division, the product of this division is less than this product. So we can see when the concentration of hydrogen is increasing, pH is decreasing. So this is the inverse relation between hydrogen ion and pH. When in a solution, number of hydrogen atom will be increasing, concentration of hydrogen ion will be increasing, there will be decrease in pH. And contrary to this, what? When there is decrease in hydrogen ion concentration, pH will be increasing. That is, we are heading towards alkalinity, basicity. And at the center, who is there? Water. And its pH came to be 7. So when the concentration of hydrogen ion rising, we could see here the pH is falling. Means its intensity of acidity is increasing. And on the other hand, when hydrogen ion concentration is falling, pH number is increasing. So inverse relationship. Now you could follow. So for this purpose, to understand simply whether a solution is acidic or basic, and if so, what is the strength, what is the not strength, what is their intensity. So that's why a German scientist, he developed a scale. We call it Surensen scale. Maniksen, Drubusen, like Surensen, but he is a German scientist. Zero to 40 pH range. What is this pH range? At the center, 7, and it is neutral. Neither acidic nor basic. pH falling means hydrogen ion concentration rising. Its acidity is rising. So in 3 and 4, which is more acidic? 3. Similarly, if the pH exceeds 7, then means the solution is alkaline. Our blood pH is 7.4. Huh? What's wrong? If it is 7.2, what's wrong? If it is 7.5?
Slightly busy. Slightly busy.
That I understand. 7.5 acid and 7.2 is also, basic. 7.2 is also basic. I want to, this is my blood pH. I reduce my pH to 7.2. And another situation, I increased my blood pH to 7.6. Any problem? Of course problem. Of course problem. I will lose my homeostasis. There will be a lot of problem. There is a range for peace. And this range is I don't want to go outside this range. Then it will be difficult for me to bring it to the normal range. There will be breakage of the homeostasis system. I'll suffer acidemia or acidosis or alkalosis. Very difficult situation these are. This may cause death. I can go to coma. You have heart coma. My brain is working or everything is not responding.
No consciousness.
Huh?
Consciousness.
No consciousness is there. This is coma. It happens also in diabetic coma. Diabetes. Ultimate stage, diabetic coma. Means the pH is imbalanced. I have some tools, mechanisms by which if there is any change from 7.4 to this side or that side, I can bring it down to 7.4. There are some tools, there are some mechanism that I am having. And these tools or mechanisms are the buffering system, buffers. train compartments. This type of arrangement is there. You have seen. And here are spring. There are spring here. They are also called buffer. Why? Here is the engine side. Suddenly it stopped. What will happen? This will push the engine, but there are buffer. This shock, mechanical shock, will be absorbed by the buffer. This will also push this. The buffers will absorb this mechanical shock. As a result, you will be safe. You will not fall. You will not go asleep. If I push you, how can you sleep? So you need push. Should I come to push you? So they are proper. We have good amount of fat here. Depositing here and there, everywhere we are depositing. Okay? This fat layer also acting as buffer. How? Sardarji wanted to fist me, hit me here. Okay? So, what is there? Fat layer. So, this punch will be absorbed. The mechanical force is applying on my tummy. This will be absorbed by my fat layer. And as a result, my internal organs will be secured. Will not be injured. If a thin person is punched, having thin layer, there is a chance of injury to the internal organs. Okay. That's why this fat layer also called buffer. It is absorbing the change. But I am failing to absorb his drowsiness. I am failing. Repeatedly I am failing. You do one thing, get a small size pencil and you put it here like this. So it will not, the lids will not close. Okay. So our blood is also, in our blood there are also buffer. So how they will help? They will not allow change. If any changes are there, it will bring it down to the, or bring it to the normal size, normal amount, okay, or normal value. So that's why they are called buffer. These compounds are called buffer. So their function is, what will be the function of the buffers? To minimize. When you will be adding acid into my blood from outside source or from tissue, you are adding some hydrogen ion to the tissues, my buffer immediately will be accepting it. If my blood is getting basic, this buffer will immediately same amount of hydrogen ion it will be adding. So the pH will remain balanced. So it prevents alkalinity, acidity, any change in alkalinity, so it tries to bring it to the normal. So these are the main function of the buffer. There are many types of buffer in our body. Why are you laughing? Now there are, before that, why it is significant, as I said, what will happen, normal range, if we go or change my pH beyond the normal range. Okay? Think. This is a cell, this is nucleus, here mitochondria, one glucose molecule entered within my cell by some means. Why it has entered? The cell need it for energy. It will convert this glucose into energy and produce ATP. It will produce ATP, and with this ATP, the cell will be doing its, whatever the function is, it will be doing its function. Now, how it will do it? What will happen? There are a lot of enzymes in the cytoplasm. In the cytoplasm, there are a lot of enzymes. This enzyme will participate in conversion of glucose by a process. Biochemistry sirs explained it to you. No. Glycolysis. Glycolysis. Now this glucose will undergo glycolysis. If the cell wants to generate ATP, then glucose has to be oxidized first within the cytoplasm, because there are a set of enzymes which will be conducting this glycolytic process. We know there are different steps. Glucose will be converted into by an enzyme hexokinase into glucose 6-phosphate, and glucose 6-phosphate will be converted to glucose 1-phosphate, and again glucose 1,6-diphosphate, and glucose 6-phosphate, fructose 1,6-diphosphate, then fructose means 6-carbon isomerized. Glucose is isomerized into fructose. Both are 6-carbon compound. In fructose, at first carbon there is 1 phosphate, 6th carbon there is 1 phosphate. That's why it is called fructose 1,6-diphosphate. Now there is 3 compounds, 6 carbon. So at the middle there will be a cut. So this compound will be splitted into 2. One is glyceraldehyde 3-phosphate and another will be dihydroxy acetone phosphate, DHAP. Now they are interconvertible. But for generation of energy, dihydroxy acetone phosphate will be converted into glyceraldehyde phosphate. Again, thus we got 2 glyceraldehyde phosphate. Now these 3 glyceraldehyde phosphate will undergo dehydrogenation, but there is an enzyme called dehydrogenase. Likewise, I am not discussing about glycolysis. So here we will find these steps are done by the enzymes, regulated by the enzymes. Without these enzymes, the participation or breakdown of glucose is not possible. All these steps are not possible. And these enzymes are protein in nature. And we know proteins have polypeptide chains, and it's not these are not a straight chain. Proteins remain in different, I think it is taught to you, structure of proteins. Primary structure, secondary structure, tertiary structure, quaternary structures. Simple polypeptide chain. Another polypeptide chain. Now both will link together. Then, since it is long, but there is no such space available, so they become coiled. They become coiled by forming different bonds. So, in this way, different forms may be there. Primary, secondary, tertiary, quaternary structure. Quaternary structure is very difficult, very complicated one, but very important about its functioning. When a cell, we have seen in case of hemoglobin, when hemoglobin doesn't bind with oxygen, its heme moieties remain inside the coil. Inside the coil. Only one heme moiety remains outside. When one molecule of oxygen binds with this heme moiety, one heme can bind, one molecule of hemoglobin can bind with 4 molecules of oxygen. Since there are 4 heme moieties, only one heme moiety remains exposed. So it will first combine with oxygen. As a result, HbO2 will be formed. When first molecule became bound to the one moiety of heme, then what happened? This binding caused some conformational change. Conformational change within this molecule. As a result, the hidden heme moieties are gradually coming to the surface. Now they can easily bind with oxygen. Before these were hidden. Now they are coming up to the surface. Now they are capable of, so suddenly its affinity of oxygen increased greatly. We will explain it in oxygen transport mechanism, where there is a curve. The curve is S-shaped. Why this curve is S-shaped, not like this? This is because of this conformational shape. Hemoglobin remains in 2 states. One is R state, one is T state. Tense, T stands for tense and R means relaxed. Okay, so these are because of conformation, 3-dimensional structure of the protein molecule. So here also the enzymes remain in a complicated structure, tertiary structure, and its active group remains within. It is not active. When they become activated, this group comes out. Then only they can catalyze the reaction, and you see the change of this molecule enzyme depends on pH. pH can alter the molecule, can make the conformational change. pH can what is this? It is protein is negatively charged. By altering the pH of the solution, I can make it positive. If I change the pH, the protein may become positive. Now it will lose its activity. We know enzymes act best in a particular pH. This is called optimum pH. Enzymes act best in a particular temperature. We call it optimum temperature. So, most of these enzymes act best at 7.4. It is their optimum pH. So, when we will be changing the pH, the activity of this enzyme will fall. It will fall with the increase of pH as well as with the decrease of pH. So if I change the pH of a solution, we are losing the activity of the enzymes. As a result, what will happen? Enzyme will lose this activity. There will not be any glycolysis. Even TCA cycle reaction will not be there. Even beta oxidation will not be there. So many reactions will not be there. So we don't want this. We don't want this. We don't want to make the enzymes handicapped. So we want they should remain in active state. For that purpose, my pH has to be within the range of their optimum activity. Clear? So this is the importance. See, in DNA, when we make the DNA strand, there the nitrogenous base, purine, pyrimidine, there are double two strands, they come closer. Pyrimidine of these bases, nitrogenous bases, they become linked together. This linking is possible at a particular pH. If this pH is not maintained, then there will not be linking. There will not be bond formation. As a result, there will not be any DNA formation. And if there is no DNA formation, so there may not be synthesis of any protein or the cellular activity. The nucleus will not be able to control the all cell activity. So there will be disturbances. Now you could see the importance of keeping the pH at a particular pH, at a normal range. So when a patient is admitted in ICU, so immediately it is the headache, so that pH is not changed. Acidemia is not developed. Alkalosis is not seen. Blood doesn't become alkaline. So it was, otherwise the patient may die. Now the buffers. Let's see how the buffer shows their activity in maintaining the pH. First buffer is important, most important, effective buffer is bicarbonate buffer. Bicarbonate buffer means H2CO3 is CO3 negative. This is the bicarbonate ion, this is the acid, carbonic acid. This buffer is present, so I added some acid. Adding acid means hydrogen ion. Adding acid means hydrogen ion. So I added hydrogen ion. If it remains free, the pH will fall. The amount of hydrogen ion in the cell will be increased, so pH will fall. Enzymes will lose activity. So what to do? By manage this hydrogen ion, so then it doesn't create nuisance. What it will do? It will combine with this. This is the one component of the buffer. So it will combine with this. What will be formed? H2CO3. Effect of hydrogen ion is minimized. Now, I remove some hydrogen ion. So it will become basic. So I am removing some hydrogen ion from the cell. What will happen? The pH will increase. Removing hydrogen ion means internal pH will be rising. So it may cause problem. So what to do? This gentleman will dissociate as hydrogen ion plus HCO3 negative ion. So this is produced, maintained. You have taken one, I have given one. So don't worry. PS is okay. But it has a capacity. If you take more hydrogen ion, then it will not be able to provide all those, substitute all those hydrogen ion. So that's why it works. The buffers works within a narrow range. Clear? So this is about carbonic acid, bicarbonate ion buffer. There are other 3 buffer mechanisms that I will discuss later.